Speaking on this day, April 1st, 2021, Thursday, start of April or stop of different season, you can say. Good morning again of April, good morning. This is to talk to you about our issue of engineering, very engineering professional issue and life issue, and this file, and of course you can say other files which are very much linked to our profession, and that is, you may say, it's a photo taken through some source of a big plant, ethylene plant. There are so many such photos which are relevant to my professional career. Of course, I was involved with this indirectly and directly both. And this is another photo, I'll explain later on. This is a plant. This is part of another same plant, one part of that. Then there is one more part, and of course you can see these move, these move accordingly, and we assess our partnership with this, various areas of that plant. I shall explain one by one. This is another plant which is called LNG tanks plant, LNG plant. There is another project here, that is one record center. This is a shooting range, another one, shooting or firing range, you can say. And this is another building in that area. And then also there is another camp, army training camp somewhere. There's another building, and of course this is somewhere in Iraq. And another building, you can say. Likewise, I'm trying to go through this just for reference, not for something else. Certain projects I'll explain to brief with you. And here's a file which gives certain buildings, method statements. And of course, there's another file which is soul of the stock. Soul of the stock, I can say. So this is certification. This is fellow membership of Institution of Engineers according to provisions of Royal Charter 1935, in which year Institution of Engineers India, which was established in 1920, and 1935 was granted Royal Charter by that time King of our country, King George V. And this certificate is for that purpose, a statutory certificate, you can say. And there is a Chartered Engineer certificate. Chartered Engineer means corporate member of Institution of Engineers India can be given this certificate, can be awarded the certificate of Chartered Engineer India, means official engineer, you can say, Chartered Engineer India. And I am attached to Civil Engineering Division because by qualification, academics and experience, I am civil engineer. And this is my certificate of International Professional Engineer India. This though expired on 30 September 2020, but it is under process. I applied for that. I don't know result, but let us see. So I close this file, fellowship file, and I close Chartered Engineer file as well. And now let us go to quality file, which is most important here. Quality means, what I mean by quality. It's proprietary of none, and of course propriety of everyone. Quality plus, then I say designs, then I say construction plus, and I say method statements, and I say then it is risks, costs, etc. And I say method statements, and then we can say cost, risks, reliability, and then we say analysis, synthesis, thinking, contemplation, application, and ultimately engineering in profession and engineering in life, both. I am saying both because one is defined engineering, recognized engineering, other one is engineering that applies in life, which we don't recognize, whatever reason being behind that. So we have to first understand this very important details. So these are quality related. Quality, after all. I really talk of quality because I want to let people take interest in this term, quality. People want quality, people intend to get quality, but in fact, people are not very serious. As I experience, I try to understand in my own country, India, Bharat, the people talk of a lot, but they're not having any determination. They don't have any level of will, and that applies to all sectors in our society. From top to bottom, talk is a lot, but achievement is nearly zero. Production is considered very important here, and production defines that it should have quality element in this, but here quality is only on papers. Maybe in certain exceptional cases it could be, but as far as I understand, quality element does not really exist in practical life, in production. You cannot be sure whatever you buy, whatever services you take, shall that give you quality? That's point here. That's why I say quality plus is a point of consideration here, which I can say systems quality, individual quality, element quality. Why I define it separately? It's only that I just analyzed into three systems, individuals, and element, and it can be added. Any other point you can add, no problem. No problem, you can do something you want to do. You may say whatever you want to say, but I think these cover when you say systems. Every organization has some system, and not only organization, its technology has got some system, its performance has got some system, its technical check has got some system, its commercial transactions have got some system, banking has got some system, transport by train, by flight, by everything has got some system, our computer has got some system, our family style has got some system, our society has got some system, politics has got some system, medical has got some system. You check whatever field it is intended to be checked, you shall find that systems do exist everywhere. But only existence cannot be justified. This should be to that level in performance that can be called it is quantity plus quality performance, or progress with quality performance. That's point which I want to raise. So I say systems quality. Systems quality. If there is no quality in system, you cannot expect individuals to perform with quality. There may be exceptional cases where individuals try to perform, but that is on, you can say, personal basis, not as a part of system. If everybody related to whatever system tries to perform qualitatively, I think scenario can change. But if some person does it, those people who are not interested in that much level of performance, they try to ignore that person or try to start teasing that person who is efficient in quality performance, who is sincere in every act of work, and who wants to do something per system requirement. And then I say element quality. Element here means everything, product, services, or whatever you are doing, I consider as element. That element which is a result of or your output of your work, is it having quality? That is a question mark. I am saying having now, present, because it was having in past, I can't say. Shall it have in future? I can't say. But what's the status now? If we can't have at this moment quality, this means in past we did not have that. So our culture has gone down to level where quality is subject to your desire, not to product or element requirement. So these are points I say. Systems according to quality system, or systems quality you can say. Your system must have quality, defined quality, and that quality must work. But question to be scrutinized is, to be investigated is, does it? That who shall do it? Only those who are involved can do it. Whether or not individual works, individual has to do it, boss of an individual has to do it, group people have to do it. Of course, everybody cannot work to that level equally, uniformly, but within certain range of tolerance, range of definition, every individual must work. So individual quality comes into question. When we select some group, we say this person I can take, this person I can take. It's not because of face value person is taken. Yes, face value is referred to performance value. We know person performs well, so everybody wants to take that person, or those who are not interested in quality performance, they want only those individuals who you can say are in tune with other one, irrespective of level of performance. And then you can say element quality. So systems plus individuals plus element at this moment we can say can be included in quality criteria. Whatever else can be included in this, you can say many other sub branches can be included, but I can say here systems quality, individual quality, and element quality are major points of considerations in this case. Then we come down to designs. What designs? I say all stages of designs. All stages. Designs means everywhere design exists. If you want to think something, you want to plot something, you need some design in your mind, though it may not be defined. Designs means something you do, something, if you appraise this, analyze this for design, you have to sign some document. What are contents of that document? Who wrote those contents? What those contents state? What communication those written document or spoken video or whatever audio speak about? What do you speak about? Contents are designed, signature is not designed. So design, we say, what is content of that? And this applies to every stage of working. It's not simply structural design or non-structural design, or design of some case, or design of some writing, or plot of some story, or whatever, drawing, some construction of drawing, some work, how to do that, thinking of that, means method, how to chart out, that is the best one, keeping up this many criteria. So whatever stage in life stands, that's called design. You might have heard in this was designed, not actual. They say, oh, this was designed case, this was fabricated case. Design where you think and produce something which clubs other. So all stages design I'm talking, design in designs itself, design in feasibility itself, designs in field itself, and designs in structural detailing, design in detailing of something, designs in construction, because so many designs are required, like working drawings, like shop drawings, like other detailings, like standardizations of work. And then redesign itself, review of designs, you can say whatever designs you have to review them. So all stages designs, I can say, is a part of designs. Then we come on to construction plus. I say construction plus. When I say construction means all activities, and all activities means there should be something based on my design mind, Based on my quality mind or your quality mind, you have to decide sequences in which way you have to go. Sequences in which you have to go, and with what time allotment, and with what time achievement of quality, achievement of standards, and that kind of formation, that kind of a sequence of thoughts, that kind of expression and writing, that kind of chatting with others, that kind of, you can say, even if no writing, no chatting, but some contemplation exists, that we can say a kind of written or unwritten method statement, a kind of statement which we can call method. That's what I'm talking of. Express detailed formation, express detailed format for performance, express detailed format for performance, which says I have to consider time factor, which can't be changed. Time is limited for everything. Yes, there can be variable, but it's unchangeable. Then we say, okay, cost is very important factor, because I want to save cost. So this is better way, or I want to do that another way, which I can justify for quality purpose, cost purpose. So that you can say invariable, though cost is invariable, but escalation can be considered minus or plus. Cost is there. Then if you say risks. Now, world of risk is unknown. It may be unknown, it may be known, but generally when it results in jeopardy of work or jeopardy of health, you know jeopardy, what I mean, to bring some danger to someone unknowingly, to let someone exposed to danger which was never expected or expected both. If it was expected, that risk can be diminished, that risk can be controlled, because we know this is possibly, there's 95% chances that this will happen. So we can say, I understand that, I can foresee it, I really understand how it shall work. But when something is really unknown, I don't know what will be result, because either I not experience that one, or I can't calculate that as a part of foreseeing. Both are considered risk. What is jeopardizing risk, and what is, preventive risks. Both are there. Even jeopardy can be prevented. So must be foreseen. Reliability is a very big factor. Reliability. What does reliability mean? We have to achieve that, because it is profession, it is life, it is business, it is commerce, it is industry, it is what we are selling. I am selling something. My buyer, my consumer, my you can say user should feel happy. He should think, that user should think, whatever is expected, whatever payment has been made, that return has come, achievement has come. Its reliability plus it is, means it is value added reliability, must be achieved, and if it's not achieved, then I am a failure. So how can I define reliability in terms of activities, in terms of what should happen or what should not happen? Reliability itself says we have to depend on you again and again. Liability, though liability is a different word, because liability means complete accountability, complete financial, responsibility, quality responsibility, every responsibility, and that is liable. You are liable to punishment, you are liable to discharge, you are liable to this payment, this and that we say. So what is reliability? In simple terms, we can say whatever service, whatever product we are selling, whatever service we are providing, that should be safe. Safety, it should be given a safety element, that it's not going to harm you, it's going to, if not better, give better life, it's not going to harm you at least. And this service we are giving you, this is able service. This product that we are delivering to you, this is able product. Service ability, product ability, or usability, you can say. I have written serviceability, because product it may be, service it may be, or whatever it is, it's going to serve you in one way or other way. So it may be product, it may be service, or it may be other kind of, whatever I say, work, that's going to serve you to whatever level, whatever degree of requirement successfully. And then durability we defined, which is very very simple word, means whatever whatever time this product was designed for. You may say, if I buy some product, it can work successfully for a number of years or months or time, that time for which it was designed, and I expected that it must function, it must work safely and with efficient service, you can say compatibility. It should serve me, it should be safe, it should keep itself safe, and it should keep me safe. And that is for a long duration, for defined duration, and that I can say can be considered durability, means efficiently working, proficiently giving service to that on that duration, and even it may cross that. That's called durability. In concrete, we say a structure is durable or not. We buy some product, is it durable or not? We say, what's durability of this car? What's durability of this work? That's a, otherwise you can say, you can remember this by saying dur means how far can it go. Dur is a word here, you can consider that it is Hindi word. So it's, though it's not Hindi word, but just for purpose of memory, we can say how far can it go. Then we can add to all this safety plus serviceability plus durability other knowledge areas factors. Other knowledge areas factors we can add to that, and I'll come to that. We are discussing about project organization, and this file I have to open. It was not open. I think I forgot to open that file, and that is I think that's I have to find it's missing somewhere in this. Yeah, it's just here. So that's project management, which I opened last time. I still it's this file is open now. So okay, this I can see this is project management, which I was talking here, and so this point has now I can say I see. So safety plus serviceability plus durability and plus other knowledge area factors. What are knowledge areas? Well, these knowledge areas are many, and this can be say what are these knowledge areas. We can go through that and see what knowledge areas are, and these knowledge areas you can say there are so many factors which are defined. 8 factors I talked yesterday, starting from I can say starting from somewhere scope, and then cost and all that was there, which we talked yesterday. I want to show you because it's better to show, and then you read yourself, because if I speak myself I may change sequence of that. So it's here, you can say it's here, and that is scope, quality, time, cost, risks, human resources, procurement, communication plans, etc. Scope, quality, time, cost, risks, human resources, procurement, communication plans, etc. That's what I was talking about now. Now we say, so all other, you can say knowledge areas, factors. Then analysis, you can say it's life actually. Analysis is a very high profile term, and people do not understand this, even those who are bound to understand this, bound to conduct this, they too do not. Analysis cannot be done by everybody. So simple answer is this. It's very powerful tool in a sense, invisible tool. It's a tool in mind. Analysis, if you can do, I think you are a brilliant one. You can be defined as brilliant person, a person who's mentally very active, a person who's sleeping guy who just wants to eat and live. This can't apply to them. Analysis exists everywhere in your life. Even if you are a kid, it applies there also. Analysis, a kind of solution it is for every problem. It exposes problem and it gives you solution as well. So analysis is, you have to understand like electronically, means what you want to understand. It's like electronically what I want to understand. That's the point we can say, means analysis. You analyze something, you get it. Without analysis, you can't get answer. And it applies to every activity in life. Every activity. You are a student, you are adolescent, you are studying, you are a collegiate, you are a businessman, you are a doctor, you are an engineer, you are a professor, you are a politician, you are a non-politician, you are professional in all respects, you are a writer, you are a journalist, you are a debater. I think you consider every field. And if you don't do this, if as an engineer I don't analyze, well, I think I can't work as an engineer in that case. Then I am, you can say, without mind. I can say that. Just learning engineering or whatever else is not enough. Learning and showing certification is also not enough. Because certificate doesn't establish that you can analyze. Certificate is based on certain syllabus that you have qualified, and that's it. And that too with variation of marks, variation of grades. So it doesn't tell you, it doesn't tell someone, it doesn't notify the person is analyst. And there is no degree of analysis because it applies everywhere, day to day, hour to hour, minute to minute, it applies. You have to analyze yourself, I say, means analysis of analysis. When you talk something, you can't talk without thinking. You have to consider that point about which you are talking. Whether it's worth talking, it's worth explaining, or it's worth taking consultancy from someone. That you have to decide. Analysis, analyze, it's a verb, analyze. And when you analyze the problem, there may be many problems and problems. You are not able to understand how to solve it. In that case, you have to go sequence by sequence. And when you all sequences, you have to understand those sequences. What is reason that that problem is erupting? Why this is erupting? What was reason? Where did I miss? Or where did someone else miss? And that points we have to extract from our state of mind, state of concentrated mind in that moment. And that's called analytical state, a state where you analyze yourself, you analyze your problem. There can be simultaneous studies of many problems one time because it's part of same problem. Problem is never single. There are so many sub-problems in a problem. So analysis is a group activity, analysis is a single activity, analysis is a bombing activity. You can find out answers through that, and then you can sequence them also within same question. So analysis is a powerful tool in life. Those who analyze, they get all answers. Those who analyze, unfortunately, this property has been missing among 98% people. People want facility. Everybody wants facility. They want all benefits. They have converted their souls to material achievements. Unfortunately, it has happened all over the world. Analysis is not sold. Analysis can be bought. It can't be purchased. This is a state of my mind. This is linked to your soul. This is linked to your power. This is linked to your energy. So you have to analyze every problem in your life. And if you can analyze problem, other meaning of analysis is reaching a solution process, swimming in a process that can take you to solution. That's what analysis is. In every field, this is applicable. In your personal life, in your family life, in your professional life, it applies. And if you can do that, well, I think you are best one. There will be no problems in your life. If you have problems, you can say you will come to know risks. What risks do exist, what risks do exist in your life. So analysis is very important part. You should understand this. In engineering, there is a subject even, analysis of structures, theory of structures, and we also say applied mechanics, material science. All these are based on analysis. No material can be understood if you don't analyze that. No method can be created if you don't analyze our problem. We have to understand atomic structure. We have to understand material properties. We have to understand how this process works. You have to understand while doing design how many forces are coming, what forces are coming. If you don't analyze that, we can't understand how to design structure. So design part is a synthesis part. Synthesis part of that. Analysis is opposite to synthesis. Analyze creates synthesis. When the process of analysis works, it moves in, that process leads to synthesis, means formation of something. So analysis means you have to count everything, you have to calculate. There's a calculated risk he took. Yes, it was calculated risk which are based on analysis. So analysis is another form of calculation. It's not numeral calculation, it's calculation of process, it's calculation of thoughts, it's calculation of understanding, it's calculation of information to get in. All that is analysis. And I say a must. It is a must. If you don't consider it as a must, you're gone. All problems to be understood, all problems immersed in or working in or available in or residing in that problem must be out, must be understood. So synthesis, you say, you are actually, while doing analysis, you are doing synthesis. Both move together. Just like you consider mind, this is my problem, if I take this as probably I get some benefit. You are thinking of that benefit. That benefit is nothing but a kind of synthesis. That's point you say. Then now we say, okay, that's what we talked of. Now all solutions network must reach compatibility. What is that? All solutions network must reach compatibility. That's what I said about synthesis. Yes, synthesis means combination or assembly or reorganization or reinstitutions of whatever problems were solved. All those be in a kind of network. Combine them together, tie up, sting them in, and you will get synthesis. All solutions network must reach compatibility. Compatibility was, what is compatibility? If there is one part, there is another part, there is one more part, let us say. These three parts are put in a machine, or whatever number of parts are there in a machine, 40 parts, 50 parts, electrical related part, or you can say battery related part, or magnetic related part, or whatever parts they are all going to solve some work. They are going to do some work. Each one should work together with other one. There should be no difference. There should be no fight between them. There should be no disparity between them. And that's what I say, compatible. Some electrical supply comes to mechanical part of machine that must be compatible with that machine. That machine must receive that service. Electrical service must support that machine. That machine must accept that, what amperage of that or voltage or whatever is that, means both should work in consonance. So all parts of a machine, when assembled together, they work together. Each part can be called compatible to each other, fittable to each other, suitable to each other. Suitability, you can say. Suitability is compatibility. That whatever I require, I got it. Within that range, it's called compatibility. So all solutions network must reach compatibility, and that's again is called serviceability and thinking. Though it's very common word, but professionally, if you consider, it's not common. It's a real word. It is electron. It's atom of everything. It is nanotechnology. You can say, if you think. What is think? Thinking, you can say, THI thin and KI thing. It can be thinking, or you can say king. Thought, thinking, or king. Yes, it is king. King in negative form. What is negative? Which can't be seen, but its value. If you go below 0, it's minus. If you go above 0, it's plus. You say in graphics, x axis, y axis. On right side of x-axis, 0 positive, this side positive, which can be seen, or other side negative. Mind works negatively. You can't measure process of mind. When I'm working, I'm thinking. I can't measure even what I'm doing, but I work, I think, I get answers. You can't measure by centimeter or millimeter what mind values in because it's negative world. It can't be exposed, it can't be thoughts. Yes, you can find solutions. It's a process, but invisible process. So thinking is negative, not negatively, I'm saying negative word where it can be seen by naked eyes, but it can be felt by mind eyes, not by my eyes, by mental eyes. So my mental eyes do have power, and that power is thinking. And if you think something, whatever you think, I think everybody thinks every day, whole not 24 hours, but even those who are called duffers, they think. Even dogs think, elephants think, cow thinks, bullock thinks, everyone thinks. And human is born to think. If human cannot think, there's no difference between human and other animals. So thinking is very important part, and thinking is, you can say, undefined material. In every material we see this electron, neutron, proton, this atom, this and that. Thinking is something unknown, but it applies everywhere. Without this unknown, you can't work. You work in whatever field. You have to think. Even if you are cooking, you have to think. If you are writing, you have to think. If you are eating, you have to think. Thinking, maybe you don't feel it, but you think. Sometimes we think, we don't know we are thinking. It's that kind of state, that kind of power, I can say. This is power, and an only way, a mark of exclamation, because it's educational, it's achievement, it's a process, it's a train, it's power of mind. Even there is no target you have fixed, but it shall take you to that target. You try it, an only way. And then coming to contemplation, which is nothing but, you can say, thinking goes to formation of ideas, and formation of ideas goes to analysis, and analysis goes to synthesis, and synthesis goes to contemplation. Contemplation means template. It's a kind of format. It's a kind of solution sheet. It's the kind of format you fill in your mind. And some of those templates, how many templates do you have in one problem? If you merge all those templates, you can say, I have contemplated. I have done it, it was expected to be done. So contemplation must be achieved. That's the requirement here. And I can say contemplation and then applications. Why I'm talking is same. Applications which must be affected, which must be done, which must be produced. So what? It is contemplation. It's very important part of life. Without contemplation, nothing is possible. I can say nothing is possible. Contemplation is an only way that we can reach that, and it must be affected through applications. And equal to what? It is equal to engineering. It is equal to engineering on both sides, plus plus and plus plus. It can be many pluses, it can be one plus, it can be billions process of pluses. So engineering is that. It's not professional engineering alone, it is social engineering, it is human engineering, it's life engineering, it's existence engineering, it's natural engineering, it's you can say Brahman engineering, it's universe engineering, whatever you can say, that covers all. That was the only reason I tried to explain something about applications, so you can say, this talk can say, what is application? This is what application. I mean, application is not a piece of paper, it's complete process, it's design, it's quality, it's time, it's cost, it's risk, it's communication, it's thinking, it's contemplation. Everything is all that. You can say compatibility, analysis, synthesis, reliability, risks, cost, performance, methods, designs, construction, quality, all these are covered in that. It's very important part of life, and that's why I said project organization and project management, which we have to talk about, because these cover everything as such. So my dear friends, means a kind of different way to explain. I was here, I thought to do something differently in this case. And before going to that, let me go through this program. I mean this explanation of plant, which actually it's a plant. Plant means it's not simple plant. It's very powerful plant. You can say many kilometers by many kilometers it is size, and you can see all these, it's written facilities, ethylene plant. It's a plant, it's a, you can say, subsidiary. Of course, there's supposed there's a refinery, and from there's that refinery you get some byproducts, and those byproducts further processed in some plant, and that's like this. It's a facility. For example, it gives ethylene from the byproducts. I'm just giving an example, and there are so many, you know, chimneys here, so many vessels here, all these vessels and processing machines. You can see this is all lighted, but at night this was taken somewhere from some project, and this is all external activity. There's a big plant, I think this very big plant, you can say, many millions and billions of dollars it should be. There are so many machines in this plant. It's very important. Though I can't give you complete analysis, it's not possible beyond my reach. Just the reference I'm giving you how engineering works. This is an example of engineering achievement. In this involved, I think there's no field left from engineering world that doesn't cooperate here, doesn't contemplate to this one, doesn't come in application here. This is an application result of some of engineering: civil, electrical, mechanical, electronics. You can say scrutiny. You can say surveillance, electronics related. You can say manufacturing, everything, oil, non-oil, human resources. There's no knowledge area which won't be covered here. It's that kind of application, and that's what we say development application, industrial application, heavy industries. This is original. This is not a production engineering alone. It's a process engineering. It's a processing machine or processing industry, and there's so much work in this. Of course, so much work in this you can't even imagine. So it's that kind of. So you may view such if you search Google, you'll find so many photographs and so many. And then we go to, let us say, some parts of this. For example, this is a cracking furnace. Cracking doesn't mean crack something. It's a part of process. Cracking some atomically, or you can say element wise, something is broken into something else. Some received material, some received substance is to be a product, received one, and then you have to crack it. That is called the furnace, and such a structure that you can see yourself how complicated could it be. And then you go to other one, and you can say, then I'll say this is you can say a kind of, if you see from top, you will see like that. Here's a sea, you can see this is sea here, and there's some structure here. You can see structure, I'm not explaining it wrong. And then you go here, you will find controls. This is an office area of this, means from where offices are established, a warehouse or something is established here, all. And this is some of the plant, and this. Then you go on there, it's of course same facility which I show, and this is here, you can say, here's the process area of this complete process area. It's all near process areas, and here also all these are there. This is a kind of, and there's a sea water. You see sea water is shown, this collected from this sea itself. If you see the sea and water comes through this one, this water comes here. You can see this line here. Water is taken from here somewhere. It's coming here. It goes here and then takes into this. Same way, there's some other buildings here. Which buildings are that? There's some lagoon here and some other outfall chamber here. All these facilities, because and we go to other one. Then same, it's called intake here. Just names are there. So I now say it's, say, for example, intake at sea, intake for water, intake at sea, or intake for whatever it is. intake, and then go to administration here, of course, and then go to process here, and then it is seawater basin. There's just few names are here. After say it's further details of this is for example admin building. It's a building of admin area. It's a building of some facilities here. For example, this is amenities building or something. This is a mosque area or something. This is the orientation chains and all warehouse. The warehouse area. These are facilities here, you can say. And then the process, a whole process area. Electric station. This is another one. This is electric engineer, electric substation. And this is different kind of piping. Have the complete process here. See, hodgepodge here and then all this. And then you go to C, and then you go to here. Flare. This is a flare tower, means disposal of all gases, final gases into weather, into an atmosphere. That's called flare. Then we go to here. This is again say landscape, showing all green in open area covered with greenery. That's simple landscape engineering here. And then you can say this is admin and workhouse. Further details of that. Admin area works off, and go to then other one. It's just pipe racks, means you can see these pipe racks are shown all moving. This big structure of pipe racks, piping columns and piping platform columns, and then foundations of that one. And these are all internal roads, service roads for this plant. Various structures. Then we go to, you can say process again. Whole process better is clear, and we see this particular portion is clear. These pipe racks and service roads and all seen here. See water basin, all that. Like go again. This lagoon, as I say lagoon. This is outfall chamber. So this whole size, you can say, not only this from other one here. You can say down here. Your coordinates are given here, so you can view that one. Then you can say here, seawater basin is a separate one here. You can say, as I said, water comes from seas, goes here, stored here, and then further transferred to, distributed to all plant. And that's seawater basin. Big structure, we'll discuss that one. And then electrical stations and roads, these are stations and internal roads. You have seen that, but this is just another picture here. And then this is somewhere else. So LNG tanks, I can say. These are LNG tanks, for example, natural gas, 4 tanks here. This is written in Qatar, which this is because we are taken from Google. So this is Qatar gas. It's written here. Project Ras Laffan, Qatar. It's written here, so it's nothing to hide in. And this is a tank here. I was here for about 1 year. This is a tank. This is a tank. This is a tank. I was associated with these 4 tanks as a part of survey recorder. You can see record of surveys. And this whole plant here, LNG plant. So this you can say. This, so I'm showing you real pictures. Means the electronic record center. This is somewhere else. This also I think Qatar is given. Consulting long. It's far in Qatar is written. Maybe somewhere else. I cannot be in the. This is a record center for Qatar Petroleum. Qatar Petroleum is a company, a national company of oil in Qatar. So this was a small project. I was in charge for about 1.5 years. 1 year probably. This is some water tank here, and this is some other services, and here is some service block and a guard room here. You can see other buildings, and this is main building here. So this is another one you can see, and this is another problem in Qatar. So I think it's firing range, shooting range or firing range. You can say it's very big structure. The structure means in a way lengthwise. This is a part of army training. This is a building, you can say, where people use it. And this open from here, from this point, if you go to that point here, this is about 330 meters. This is open. This is bullet trap chamber. Bullets are trapped in, and these are complete. This is wall here. This is wall, 6 meter high, 10 meter high. This is another wall, and this is completely open to sky. All this area, and there are subways, one here, and one here, and there are so many gantries in between. So this is a kind of training center, how to shoot, that teaches. This causes a firing range, 300 meter length from here to here. This is shooting range here. This is firing. This is indoor. This is closed. This building is also covered. This portion where I shown. This is shown on Google. This is open, and that's what is there. Some of the facilities. If you go down, it's a big one. Complete RCC means this complete RCC work here. RCC baffle walls, and this is RCC building. And if you go farther down, then you will find some other buildings, ordinary buildings, And that means a kind of whole plant, whole not plant but center, army training center. This is, and of course you can see this is again army training center. Another view of that, where firing range is shown here, you can see, and the sports complex is also shown somewhere. So it means the same. I'm just trying to explain to you. Then the sports area in that case here, in same plant, same area, and also here. It's Iraq now. Iraq. There's a complex here. This building you can see. It's a press complex here. In this building, I was here in 1981, 82. You can say about 39 or 40 years back. I'm just showing you how it was in those days. You can see this is very Baghdad, here Baghdad. How beautiful it is, how quality-wise it is. Here it is press conference. It's called Qasr Mutamarat at the time. Press, means palace conference, palace. It is called in those days when Iraq-Iran were in conflict. This is that building was there for tower, and you can see beauty and quality of work, the quality of layout it's giving. And of course, there's a beautiful building here. Those are not little construction, but it's very beautiful building. You could not even remove your eyes from here. It was so beautiful. It was in view. And same if you go here, the same building I'm talking of, which I worked in this Dawan, this one here. We worked for that building, and of course, a great experience I had there from. Then we can say that's what I can say is there. So this I tried to show to you how it works, how does it go, how does it behave. That's what it was. I'll close this file now because it's gone. I can't keep all files open because it consumes memory, and the video can be disturbed if too much memory is taken. That's the point where I had to video. So it's now, I'll close it. If I require, I'll open it again. The purpose of this is over. So I close this file. Why these people are disturbing, I don't know. What is that? I don't know. I will be disturbing for nothing. So I come back to same point which I was talking. And this, and that is here is gone. Or say yes, I was talking about organization, management, and that's what's about here. I can say scope, quality, time, cost, risks, human resources, procurement, communication plans, which we discussed, and we had to go on. And then I think we reached somewhere, I don't exactly remember. Yes, we covered this also. We had covered this point too in our last talk. And we had to, yes, we talked about charter, and we talked about charter and quality standards to be on deliveries. So let us again just have a review of charter so that we can refresh our what we could study in that. So scope, charter, that is decision making stays about project and authorization of charter. That was the point we had in our mind, in our consideration. We call it front end engineering designs, means FEED. Description of deliverables, contract requirements, contract sufficiency, specifications, duration, charter, risks involved, stakeholders, shareholders, sponsor, financer, contractor, clients, consumers, organization, partners, subcontractors, possible investments, possible returns, possible reputation enhancement, prestigious or ordinary project, other projects in hands, capacity of organizations, expansion of organization, maybe project discarded currently, project manager and all other depending on type of considerable project, resources allocation, charter authorization, etc., etc., etc. This is what we have already talked of, already deliberated on charter. No need, I think. However, All these points and maybe many more such points can be included in descriptions charter for reference in future when we investigate where did we make mistake or why did we elect this work to do or this bid to offer. Depends in future means were we ready for this or we were not ready for this project or we blindly take decision or we feared someone against our organization. All these points when we have to consider in coming time due to whatever problem, change of board, change of something, or even then we have to investigate our progress of business, why we are not achieving what we expected. All those points are considered in that. This becomes a foundation to know how our loads coming are not accepted by this foundation, are not transferred accordingly. And that's purpose of charter means everything should be in writing and this should be approved by company organization. Means why did we elect something, why did we do something, that must be clearly in black and white and blue and it must be in writing. There should be a combined responsibility for that. You can say total responsibility for that. That's not an individual one who is responsible because you have to respond to all stakeholders. And in fact, stakeholder representatives are also responsible for that equally. So that's what all these points cover in charter, and this is what you can say unchallengeable, because we are saying contract sufficiency we have to take into consideration, feed we have to take into consideration, deliverables we have to take into consideration, what are contract requirements we have to take into consideration. All those points must be well understood. What's duration, what are risks involved in this charter, in this work, and you can say finances from where we'll do, and who shall be our contractor, possible contractors, and we know our clients, our consumers. Like that, we know everything must be clearly understood. Who can be subcontractors, what's investment in this, what are returns, what's percentage of returns, is it feasible or not, is it invoice level or not, or shall it give to enhance our reputation in market, shall we move forward keeping when this is included in our pre-qualification, shall it benefit us. It may be prestigious projects, ordinary projects, or shall we can say worldwide level project. All this we have to understand. Who shall be liable for this? Who shall be leader for this project? All this point we have to keep in our mind while establishing charter. That's all. Then we go to quality. Now quality standards to be achieved on deliveries. We talked of this quality at length in this on this page of quality page, which page we will repeat every day, because every day mind thinks something. You have to think problems. There are hundreds of problems in life, and every problem has different analysis, has different backing, which we have to understand. That backing is very important part of life. We cannot simply move without backing. So quality standards we achieved on deliveries, that is sole point. And we call, when we say quality, it's simply not quality of some one point, it's total quality system, that's what we call it. And quality requirement is already known, it's defined within certain tolerance, within certain limits. Nothing can be achieved unlimited, and this limit also keeps on varying. No fixed limit. If we can say we can expand this limit, we can expand if we want. That's up to us, because it's a question of relevance to time, it relates to cost. If cost is not affected, or if we improve our performance, we value our time in same time, in same cost. If we can perform better, if we can give better results, better you can say product, that can be called value added product. Means whatever it was required to do, that product gives that, plus in addition to that it also adds some quality criteria onto required quality. So we can say quality requirements or quality plans. We have to prepare for that to how to reach that quality requirements delivered or meet. Then we can say quality plans are drawn, and quality plans you have to decide what way it is, which you can say becomes a quality procedure, and also how to perform that quality plans tells you performance about, means that procedure which is involved shall lead to certain performance word, performance level, performance quality. So quality plan gives you inculcation, it gives input of quality plans for the performance. Or value of financing or quality means what quality or value of financing, quality of procedures, quality of competitiveness, which is a very important part in life, quality returns on investment, standards of quality. You form standards itself. Sometimes they say, oh, we can consider this as a standard. And then quality implementation, degree of achievable quality on project, optimum quality for optimum profits, quality possibility for all sections, relevant to project, value to be achieved after project is delivered, quality meeting or exceeding customer or end user expectations, value to be provided by project deliverables to client or owner. So we can say quality can be defined, we can say divergently, but quality definition must be quality one. Total quality, we say total quality means total system. That system must be very competent, it must be organizable, it must be handable. We cannot make, you can say, something hanging in air. We need some balance, some equilibrium. Airplanes work not because of their structure below, but of aerodynamics. Same way we must have some dynamism in ourselves. And without that dynamism, we cannot move. Every force is stable because of its equilibrium state, dynamic equilibrium. Same equilibrium we must have in mind in our performance, in our process, in our process train, and that organization or management must be called quality one if it is to some defined level. It is remarkable, it works, it gives quality of expectation, quality definition, it gives standard matching quality requirement. We must have that plan. Our plan must tell what is what, who is what, process is what, how do we move, what is our scope, what's our goal, what's our policy, how shall we handle every problem, how shall we move into quality procedure, how can we define our procedures in a way it's understandable, it's understood by everybody or group of people working at one place. Quality procedures, how can they perform in unison, how can they perform in harmony without any degree of difference, which is called, you can say, performance quality. Means a group has to perform not to fight, they have to perform without any heterogeneity, and if there is some heterogeneity, it must be parallel to homogeneity. Means they should work together as group. And individual performance should, of course, it will vary from person to person, but not that much. You can say plus minus 5%, 10%. Quality or value of financing. After all, this is what quality you want to intend, that's where you finance for. Actually speaking, we finance for quality along with quantity. We cannot simply finance something, oh, I have to finance it because I want to get so many products done per day. But that must be with quality, that's what I'm saying. So quality of procedure, it's a question mark. Quality of procedure, relates to value of financing and requirement. Then we can say quality of competitiveness. Competitiveness is a mathematical term here. You can say value. Who is your competitor? Means who can be in same range your stand. There can be plus minus 0.5% or 1% difference. If you see a person who gets prize number 1, first prize, and a person who gets second prize, you'll find difference between them is negligible. It's ignorable. Even 1 second difference can get someone first prize and someone second prize. So same thing is here. Who is your competitor? Or your competitor can be better in quality than you are. Simple. Or you can be better than that. It's same thing. But sometimes, calling competitor more qualitative doesn't mean all time that competitor is quality oriented. You can also do better. It's up to you, your determination. So quality of competitiveness is very important. Means though they are competitors but equally important, because there is no much difference in their performance. Little difference. But if there is a lot of difference, then there is no meaning of calling them competitor, because they do not stand anywhere where you stand, where you are. And we can say quality returns on investment. Quality returns, we can't say you can make my money in 3 days twice or thrice. This is not quality work. Quality work doesn't give you unexpected multiplication of money. Yes, within some range is fine, within tolerance, okay. How many percent will get on this? We'll get few percentages on that. So that's what I say, returns on investment. Returns can't be in form of money only. Returns can be in form of enhancement of your reputation, build up of your image, your fame of company, your standards. People consider your standard. Landmark, like we say, this landmark. It's a landmark in quality. Oh, this company gives quality, we say. We don't give address. Oh, see, this company is very good in quality. So we can say standards of quality can be defined, can be established also. It's not necessary that we should go to standardized organization to get standards of our quality. We can establish ourselves, and that is where it's required, means professional one. Professionally, we have to establish our quality criteria that we can perform in this range. Then you can say quality implementation. Quality we talk of, can we implement it? And if we implement it, is it going to way which we are thinking of? This means it depends on your analysis, it depends on your terminology, it depends on your considerations, it depends on your, you can say, how did you combine them, all solutions. And implementation is that much, destination which you deserved, you designed, and you had to implement. Quality implementation, only implementation can prove that it is quality work. Quality implementation is that. You have to implement that quality, only then you can say your product is worth this quality or this specification, or it is not worth. Degree of achievable quality on project. Yes, degree of achievability I am saying is sometimes you achieve quality, sometimes you achieve a little lesser than expected, and sometimes you can also get more than that. So what is degree? Substandard work which you get in comparison with your quality standards cannot be called quality work, because there is a deficiency that can be rejected or that can be sold in different value. So quality possibility, how much quality is possible in your work? Can you get 100% or 90% or 110%? So degree of achievable quality on project, quality on project. Optimum quality for optimum profits. Well, this is actually, I think, only outcome of optimum quality, because when we say optimum, which is uniformly acceptable by everyone, means optimum level is called practical level. Optimum quality for optimum profits. If you are getting marginal profits, it should be marginal quality. You can't give best in marginal quality. Of course, for certain period you can give for promotion or business, but that doesn't guarantee anything. So optimum quality for optimum profits. Then quality possibility for all sections relevant to project, not only to one section but also all. Value to be achieved after project is delivered means what value shall be achieved once it is delivered, means when project is gone and its performance has come into picture, its service has to come into picture, and quality meeting or exceeding customer end user expectations. We have to consider whether what we are producing and what our customer expects. You must conduct surveys on that, and it must be done. See, our consumers are happy to this level or not happy to this level. Value to be provided by project deliverables. Whatever you are going to deliver, that value is counted to client honor. So that's what you can say. You can speak on lot on this, but just the other thing. Then comes time, significant factor governing project stages. Time. What time? Question is very important. Everybody knows time. What's time by your watch? What's time now? What's what would say? You can say time. No, I'm not talking this time. Not this time. I'm talking gross time. I'm talking project time. I'm talking production time. I'm talking universe time. I'm talking something. I'm not talking relative, means time significant regarding project stages. Significantly most valuable factor that may govern acceptance of project is time. That may not be allowed in excess of agreed, keeping in view competition as well as additional cost that additional time may require. Time not allowed to vary. Time allowed to squeeze for valid reasons. Time schedule acceptability. Effect of time schedule by force majeure. Effect of contracts and contracts by standard provisions such as FIDIC or non-FIDIC agreements. Effect on long lead items. Effect on importable items. Vice versa. Effect by such items on project schedule, time recoveries, methods, critical activities, stages, crashing time, schedule, fast tracking. These are so many descriptions given here. I'm talking of time which is quantum. It's not hours, it's not minutes, it's not seconds. It's a value. When we say time of project, just like say cost of project, just like we say what is project, destiny of projects, just like we say contents of projects, I can say time is same. No project time is wrong term. Every project has a time. We must understand that you start something and you cannot keep an unlimited construction of that. Okay, no problem, we start, every day we do it, let us see how long it shall take. You can't say that's performance is professional. You have to define time based on quantity. Means time tells you what your speed should be. If time is limited, this means you want to expedite project, you want on priority basis that construction, because time is limited, and that limited time is called duration of project. Here time means that it doesn't say on this date when you started to think of this project, but that time which you allot to all activities to go successfully, that value of time is important. That is quantum, you can say, quantity of time, I should say, long journey of time within that limit. And that's very specific, because that doesn't come from some date, it comes in terms of value. 1 year, 2 years, 365 days, 390 days, whatever it is, 5 years, 10 years, that time which is defined in contract data. I'm talking of that time, which is very significant factor governing project stages. With what speed you have to move, you have to be very smart, you have to be very lazy, that depends on that time. So this time which I'm talking is not time hours, it's time of value. Value time means time has some value here, in which you have to start this project and you have to end this project. whatever project may be, design project, construction project, sale project, or can say whatever else project is. So that time is very important. You have no right on project to waste either 1 hour of that time, 1 day of that time, because that time is yours. And if that time is lost, that time can't come back. We have to understand. If you lose 1 day on a project duration, it means something. You lost 1 day. Later on, you may recover that by spending more money or mobilizing more resources or more human resources and machines and other data. You can, but that is risk control. Time is under risk. You can't say time should be under risk. After all, it's time of project. And you can't do anything if that time is impacted, if that time is, not well understood, it's wasted. It will impact on your cost. It will impact your quality. You have reduced that time to something. In full time, you did not do anything, and so you are in jeopardized situation. That's called job assessment. Even from a single day onwards, you have plenty of time. Don't worry about that, because there are people who know what time is. They can at most say, okay, you put this geyser on and heat water till I come. Your geyser will heat water, but with time. That's what I say. You can heat up your project with time consideration, and that time must be there. You should do everything before that time, and that's required, which depends on quantum. So time is also quantum here. You can say you can't change it because it's defined. Yes, you can give delivery before that. Nobody will mind that, but of course, giving delivery before much consideration or much, you say, also is a question mark. That impacts on efficiency, that impacts on process, that impacts on your investment, and that doesn't bring a lot of investment. That point you have to understand. That's why I say significantly most valuable factor that may govern acceptance of project is time. That may not be allowed in excess of aggregate keeping. Aggregate keeping in view completion as well as additional cost. That additional time may require. Time not allowed to vary. It's not allowed on contract. It's not allowed. You can deliver contract before time, but you are not allowed to vary it. It is there. It's there not only in you, it's elsewhere also. So you can't vary it. Time allowed to squeeze for valid reasons. Yes. Time schedule acceptability, effect of time schedule by force majeure, effect on contracts, and by standard provisions such as contract authorizers, contract documentators like FIDIC or non-FIDIC agreements, effect on long lead items, effect on importable items, and vice versa, effect by such items on project, schedule, times recoveries, methods, critical activities, etc. So we can say tracking, crashing times, tracking. There's so much involved with time that you need some contemplative thinking how to recover to value it still before we did think to control rain like that. So time recovery method, if you lose it, you have to recover it. Critical activities, stages, crashing time, schedule, fast track. So you have to take a lot of it at times if you lose time. It's very easy to lose time, but it's like imperfect, like imaginary work. You think it will do, no, it won't do. Lost is lost. You cannot bring it back. You cannot bring it back because it doesn't come back once it goes away. So time must be preserved. Time must be used properly. You should know what my next day I have to work and what people worked last day. That's what time requires. So time is very important factor on project and its knowledge area. If you know everything about some project, you may say, well, we have to be next in this. That's okay. Then we want to go to cost. Cost. How does cost affect all parties involved on project? It's very important point to consider, because ultimately it's cost that is, after all, you work for. What work we do whatever work, it's for cost. That's what contract is. If cost is not defined in contract, means consideration is not defined. Cost is consideration. Means these works I have to do as a contractor, and I have to get this cost or consideration from you, my employer. You employed me for something, you have to pay for that work. That's contract sum. And I have to deliver you what is given in scope, and that is job. And that's for cost, which affects all parties involved in project. That's cost effect. Do we understand that? Which part is going to affect? It affects all parties. All parties can say cost on proposed project, maintainable cost for project, cost on proposed project first of all, then maintainable cost for project, then maintainable variations, provisional cost, equipment cost, construction cost, resources cost, prime cost, cost in long run, annual expenditure, budget expenditure, budget provisions, loss of cost or profits should project be shelved. Project be shelved, a very big mark. If it comes to that extent that we are forced to shelve project, what is the effect of cost? It's terrible. You have to shelve project because of cost. This means cost which is already gone won't come any time. It won't be back. It won't be recovered. So it's a cost. I have to spend my money, investment money, wherever it's required so that the project comes up. And project cannot come up if you don't have those ideas. That's point of importance. Cost. Time run can change cost. Simple. And time run and quality-less activities can change cost, can change time, and time impacts on cost. Time impacts on cost. That's where problem lies in. If you understand cost point, why do you say cost analysis? Cost analysis is conduct. Just like other analysis, cost is also analysis. Cost is summed up based on various analysis in contract. We work out quantities from drawings or from other areas. Drawings are with us, specifications are with us. We constitute items or procedures into one item. There are so many processes on site, which ultimately are clubbed into items. So your page on that file goes on increasing. You are saying this is my analysis, or this is my computation of value, this is my computation of, we call it quantity surveying. Quantity surveying means you have to define what's quantity of this material, what's rate of this material, and then what is final answer to this. So cost is a very important factor which can be impacted by time or can be attacked by time, and which can be affected by institutionalization or ending institutionalization. It affects both. So cost is that factor we can't ignore. Cost is fixed. It can't be augmented. You can't freely augment it until there is a requirement for which you require more budget. And you don't have budget. You can't do project complete. So if you can't do project complete, either you have to leave that project at its stage, or you have to arrange some finance from somewhere else to that project. So costing is very important point. Coordination, costing is very important point. So don't take it for granted. Cost can be impacted on even by time, and time can be impacted on everything. So you can change time, you can change your services, but you must have changed something wrong. Then you can say risk factor impacting all above. Risk factor, after all, this is very important time. As we said, As you said, scope, quality, time, and cost. These do affect project scope, affects quality, affects time, affects cost, affects. These do affect project by impacting of certain risks, by being impact of certain risks. All such risks should be anticipated in advance for applying and applying preventive actions or solutions. When we say preventive action, if we have knowledge, if an idea how to prevent this risk, it's best way preventive actions we can take so that risk should not come. It should be solutions only. Or you can say risks can be converted to opportunities if it's possible. So we can avail this risk. We got solution in hand, so we can say now we can improve our this activity. You may say this is a risk leading to opportunity, or safeguard. You may say. Now, in case preventive actionable solutions are not available, 100% risk responsive methods or plans should be produced. If you don't have preventive actionable methods, you don't have solutions. So 100% risk responsive methods or plans should be produced. 100% risk responsive, not responsive. They are risk responsive, means which can solve, which can encounter risks, which can respond to risks. Those methods or plans should be produced after having understood details both by indicated or considered critical risks. Certain risks may be considered as indicated below. We will consider them now. A risk is very long chapter. You can say, you can go to whatever extent in risks, and it's really very important point. And everywhere risk impact due to change in scope. Its risk is risk. No one can handle it perfectly, but experience can make you understand what can happen. And that is by memory, by observation, by experience, by everything. You can say it's that one, and that one is important one. You can say that risk impacts, as we have to study this lot. Our experience can take us to a point where we can say, based on my experience, based on my pragmatism, based on my knowledge, based on everything, I am doing this. I have power to solve, power to respond to this risk. This risk can be contained in, and this risk can you can say can give me this solution also. This risk can lead me to availability of opportunity. This risk can help me. This risk can lead me, can direct me. That is very important point. And risk impacts due to, you can say, various reasons which we have to confer with, and that is risk impacts due to change in quality standards. There's another point is there's risk impacts due to changes in scheduled time, and then there is risk impacts due to changes in cost, and that risk impacts due to partly unknown scope. And then risk management plans we have to talk of. So these few points we have to understand first, and that is about risk factors. We can say these are few factors, doesn't mean these are final one. These are just by, you can say, assimilation of experience. You can say this risk factor works. I can say risk impacts due to change in scope. This is you can say beyond everybody's control, because ultimately change in scope is authority of owner or employer. If scope is changed, change doesn't mean additional, it means both additional or deletive, or you can say omission, addition or omission, both cover both items. Whatever you can add to contract or whatever you can omit from contract, Both are involved. Both are risk impacts due to change in scope. Additional or deletion, addition or deletion exceeding agreed percentage levels. If there is addition or there is deletion, there is omission, you can say beyond agreed percentages, they will say 5% to maximum 10% on available cost. You can say if beyond goes beyond levels, certainly it will impact risk. This is a risk and it will impact on project. When project charter has not been prepared based on complete understanding of project implications that are generally defined within body of project contract clauses and project specification documents, and when deliverables have not been correctly listed, project is generally impacted when it belongs to lump sum contract category. It adversely affects budget cost, contract time, and performance quality. That's what we talk of risk impacts. I'll be back within a couple of minutes. Meanwhile, I give an opportunity to read at least some of this. I'll just, if you can read this, I think it will be better for you to understand. Recap. So, risk impacts will change in schedule time, etc. If you can read this, let's give me 5-10 minutes because it's all of 5 o'clock and I think it's more or less covered more than 1.5 hours. I'll just take 5 to 10 minutes. Please excuse me for that. I'll be back in that time because it's important one. I had to walk a little, stretch my legs because I know I'm patient, yet I'm trying to do something in your respect. So hold on please. So back again, back to you with same point of view of risks. I think we have gone through that successfully. So we are discussed about risks changes, change in scope we say, which is very difficult these days. Then we can say quality standards. Let us say again, this impacts due to change in scope. I repeat this because this is very important change. Scope, omission and deletion beyond certain percentages are not permitted, and in contracts even this can't be permitted. You can say omissions or deletions, additions or omissions exceeding certain percentage levels certainly impacts on risks, and that when project charter has not been prepared based on complete understanding of project implications that are generally defined within body of project contract clauses and project specification documents, and when deliverables have not been correctly listed, project is generally impacted. When it belongs to lump sum contract category, it adversely affects budget, cost, contract time and performance. That's where I'm saying in these factors, that is scope, change in scope is very much unbecoming. It becomes unbecoming when we consider that. It becomes unbecoming. We cannot say that what we consider is right, not. So addition or deletion exceeding certain percentages which are defined in contract should not be encouraged, because it shall impact on time, it shall impact on cost, it may be plus or minus cost. Even deletion to certain extent, it impacts even because your profit is 10% sometimes mainly, and that can impact on that also. So we have to see when project charter has not been prepared based on complete understanding of project complications. So we have to consider that lump sum fixed price contracts are very critical. Cost changes cannot be accepted beyond certain limit. So impacts must be understood, because it will give impact on budget, cost, contract time and performance quality. But you can't avoid this also within some limits, because owner has also a right for changes in requirements. You cannot divide owner of that right, because it's not one day contract goes on for years together, and also design goes on for months. So a period of say couple of years can bring changes onto scope of work which cannot be avoided. So this is a flexibility coefficient, you can say, is a flexible requirement. You have to be flexible in that case. So risk impacts due to changes in quality standards we have to take into consideration, which is also a very important factor. Now, you can say quality standards. Quality on works. Quality on works, if enhanced or produced substandard. So there are both ways. If quality is enhanced or upgraded or produced substandard, both can impact considerably. These quality impacts considerable risks Substandard quality results in rework. Substandard quality results in rework because it's not going to be accepted. Certainly, it won't be accepted. If it is investigated, if it is checked, substandard quality results in reworks, while superb quality, then agreed, results in both time loss as well as cost loss. Moreover, let us see what I am saying. Substandard quality, below standard quality, results in rework, which means what? Let's understand this point. Substandard quality means you performed or you are delivering something which is below standards. You are doing something which is below standards, and below standard means it can't be accepted, it can't be paid for. And if it is below standard, whatever work shall be done on this in sequence, resulting sequence, that shall also not be paid. Because if it is in sequence of substandard done, and that also, even though that is standard one, that should be considered substandard because it's founded on substandard work. Substandard quality results in rework. So first what we have to decide, if we have come to know that the work is substandard, not to mark expected mark, and there is no solution for that, or there is no substitution of that practically, that work is rejected. And when that is rejected, means you have to work again. First you have to dismantle that and then to work again. That's called rework. So substandard quality results in rework. While if it is superb quality, it is more than what was expected for that super quality, then agreed for, which results in both time loss because you spend more time on that probably, and cost. Probably you spend more time on that, and also probably you spend more cost on that. So both won't be paid separately. No time shall be paid, and no cost that's more than to be payable shall be paid. So that results in both time loss as well as cost loss. Moreover, quality requirements must have been explicitly understood at scope formation phase and must be clearly documented within charter. We must know what is our quality standard, what's our quality plan, so it must be clearly defined and its limit must be clear. Applicable codes, standards and market practices must be correctly documented for consideration and guidance. Procurement based on substandard quality shall not serve any purpose whatever but otherwise jeopardize project performance after being rejected and contribute to requirement of additional time or additional expenditure or cost and time overruns. Detailed quality management plan, detailed quality performance or implementation or organization plan is a requirement on every project. So what we said in this is very important point of quality standards. It can't be taken just for reading. It requires to be explicitly understood. As I said, quality on works makes an impact. Substandard one gives you losses of time and cost and unacceptability, and if even on that follow up you do further work, that will also be considered unacceptable. Substandard means can't be accepted. Quality can't be accepted. So you have to remove that and work again. So you know what loss is there? You have spent cost, you have spent time, and on top of that, non-performance label on your head. That's the important point. And if you do more otherwise, superb, you are going to spend time, you are going to spend cost, and of course you get some reputation on that level. But you have to think of that. It can't be always true. We have to set standards, keeping in view restrictions of time and restrictions of cost everywhere, because whatever we are paid for something, we have to deliver only that. We can't deliver beyond our profits. Moreover, quality requirements must have been explicitly understood at scope formation and as in charter time. That must be clearly documented, defined. I can't say defined in details, but defined indicatively what we have to do. Wherever applicable codes, applicable standards, and conventional practices, industrial practices must be correctly documented for everybody's consideration and for purpose of future guidance. And procurement based on substandard quality would not serve any purpose, whatever it would be, but it would jeopardize everything. It would jeopardize project performance after having been rejected and contribute to requirement of additional time or additional expenditure or cost and time overruns, and time can't be recovered. Detailed quality management, organization, implementation, performance plan is a requirement on every project. This was a little explanation I made. I'll jump onto something else now. Let us say plans. Some talk in that also very important from this point of view, because I'll come back to another one. Sorry, just taking some water. Okay. So I come back to this point of plants. I'd like to discuss something which is also very, very important chapter. I already talked about this method. About RCC valves I talked of. It's a very important item. And also I talked of other items. That is, you can say, let me come, you are browsing it, you can see also what were methods involved in that. I come on to construction of main substation. This I think I discussed, but it's very important one. Substation. There are 8 points in that and 7 points we discussed before. So I think we discussed also this one, stage 2, stage 1. And then we can do it if required again, no problem. Let's go what's after that. After that is construction of floor slab, central control building, that also we discussed. Grade slab. And we have to come to, mortar for block work. Mortar for block work cross, and seawater basin baffle walls. I think this is important one, baffle walls, seawater basin. Then this is same, I showed you in sketch that plant, real plant, this is, and I think that is then seawater basin minor concrete repair. So we'll hold on here, and that is seawater basin baffle walls concrete pour, which is very big pour, you can say 10 meters approximately. It's approximately 10 meters high, maybe more, maybe less. Seawater basin, baffle walls. Index is same, and we are talking of concrete pour here. Purpose of this method statement is to define pouring baffle walls, which are 9 numbers located on deeper end slope. This is a drawing and section is given for example this. That is between PCG, name is construction joint, and commencement of wall obviously with all that 5.3 meter slope. So since no provision of starter reinforcing bars has been made for slope portion at slab base level for baffle walls to be connected with them to ensure structural stability, proposed following operational descriptions for construction execution of these elements. So it's the scope only. Now drawing is reference, and for general definition responsibilities are given. So safety also is given, but only point that we know all safety applies, but only point that is in addition to that described safety is significant, and that is since heavy RCC activities are involved on baffle walls. This is RCC item and heavy item. These activities of heavy RCC activities are involved on baffle walls, preparatory works and pouring concrete up to height more than 13 meters. See, it's 13 meters. See, pouring concrete up to height of 13 meters, you can say it's about more than 3-story building, 13 meters. All measures should be resorted to regarding safe scaffolding, stepped access with handrails, all strong working platforms, all procedures necessary on formworks, all procedures required for reinforcement, fabrication and placement, and on top carrying out concrete pouring to proven technologies. Let me see if I get out of this something. If it's possible, let me try. If I have something I remember, I may not be having. It's not true. I can't be until I go through that. It's here, I think. Let me see if I can do it. And I can find management documents, the statement, sectors, sketches. Okay, let me see. Sketch. I've got this one. Sketch here. Yes, this is sketch here. You can see this is sketch for that. Let me rotate it if I can. Let us see. Okay, this has been otherwise. Let us see. Let's go once more so that it comes to same position. Okay, this is, you can say, this is where I'm talking of. It's shown 10 meters here, but okay, no problem. 10 meter what? It's 13 meters. The statement saying seawater basin section for cooling water distribution to industries within facility. Expansion joint average 7.5 meter on basis slab RCC structure. Safety requirements are, you see size of this is 100 meters, and here it is 80 meters, a big one, 80 meters by 100 meters, and 400 mm wall thickness, RCC wall thickness. Safety requirements: excavation to 6 or 8 meters deep, all excavation safety required, dewatering may be required, blinding safety required, concrete protection safety required, foundation safety procedures, RCC wall safety procedures, walls working platforms, pump room walls safety, pump rooms roof safety, all internal external scaffolding, concrete protection to RCC, surface safety required, safety during water tightness testing. So this is just given as expansion joint at 7.5 meter, 100 meter by 80 meter. Seawater basin plan for cooling water distribution in industries, and this portion is 40 meter, this portion is 10 meter, this portion is 50 meter, total is 100, and base slab is, you can say here 101 meter, I think 500 here, so we can say pump house outlet is here, this 10 meters. So this is dimension only, so we should not worry about that. Let us see now what it says. in this case it says that it is sketch as shown to us indicated. Now there are certain stages in this, and those stages are what, you have to understand that point as well. What stages are there? It says stages are: stage 1, pouring walls in full height. Pouring wall in full height between walls designated M and construction joint. So what designation is there? We are just understanding practice, understanding method. So stage 2, pouring portion of pouring portion of baffle walls, between construction joint and walls, portion of baffle walls between construction joint and walls, and up to a level of 7.14 meter from slab base. Stage 3, pouring remaining portion of baffle walls from level 7.14. Okay, this is the according to the sketch. We will now how to pour, that's important here. Following activities shall be required to carry out. Following activities shall be required to carry out. Let me just blow it up a little more. Hold on, please. Okay, it's okay. So is following activities shall be required to be carried out. Respective baffle walls construction. Number 1, fabrication of reinforcing bars, either at fabrication shop or at site, depending on standard arrangements and customized work. It's better if you do on site. I think it's better because it's in your control, and if you do it in site, other way, fabrication yard means better if it's done before you, because you have BBS, you have everything, you can check if they start. So fabrication of formwork sites for walls, or procurement of standard proprietary materials, that is from vendor based on respective designs to sustain liquid pressure from such height. Or this is fabrication of formwork, because formwork is too high, 13 meters, fabrication of formwork sites for walls, or procurement of substandard, not substandard, standard, fabrication of formwork sites for walls, or procurement of standard proprietary materials from vendor based on respective designs to sustain liquid pressure from such height. That's very important point. Height is 13 meter or 10 to 13 meters, so it's around 3-story building. So pressure, we know what pressure is, but it's not going to be filled in 1 hour. We have to understand that point. So by the time we reach heights below, concrete would start being solidified little. So pressure is not directly, you can say, yet it must be calculated accordingly, and our thickness of ply, our fixing supports, everything should be accordingly, so that wall can resist forces imposed on this due to fluid pressure. Fluid pressure is a depth is considered WH intensity. At depth, WH per square kilogram, tons per square, whatever you call it, it's a W into H, that is tons into tons meter per square meter at certain whatever height. And then horizontal pressure, whatever is there to be registered by system we produce, and that is formwork system, fabricated formwork or vendor based formwork or our own formwork. Height is more than 7 meter in one go, 7 meters or 8 or 9 in one go we have to do it, which means strong formwork is required to resist horizontal hydraulic pressure, fluid pressure, which requirement should be provided satisfactorily by vendor. Vendor can calculate it, and they must have very strong pieces that can be made in panels. Scaffolding and working platforms, temporary work you can say. Scaffolding and working platforms may be provided, shall be provided, not maybe, shall be provided to reach all heights up to more than 13 meter, including all stepped staircases and relevant protection. Fixing reinforcement at required locations, well tied with connecting reinforcing bars. Inspection of all such reinforcing bars by quality engineer and engineer both, Actually, inspection of all such reinforcing bars is done by all engineers present there, maybe site engineer, quality engineer, contractual engineers representative or resident engineer or whoever, and providing inserts in if so required. Whatever inserts are there may be pipe inserts, there may be electrical, there may be other inserts like catalytic protection, there can be anything. Providing inserts in if so required. It's required. Providing water bars, very important item. Providing water bars at construction joints, locations, according to indication on drawings, because water bar is water retaining structure. So water bar is a must, plastic water bar, PVC water bar, central located, of course, and wherever. If we are taking one go concrete, so only at joint below. If we take two goes, then in middle also where there's junction of new concrete, old concrete. So providing water bar, construction joints, locations as indicated on drawings. Providing tie rods or providing tie rods, say, and lost members. Tie rods means steel bars which we will use for tie, and lost members we are saying when we insert PVC pipes in that for permanent inclusion, that we can say lost member, because we can't take it out but it will be sealed by waterproof material. So providing tie rods and lost member, here lost member is PVC pipe. Closing all reinforcing bars by formwork shutters. Of course, shutters, formwork shutters, ensure verticality and alignment by checking plumb bob. Plumb is not ordinary plumb. This is height is too much. Maybe we have to use hanging binding wire and some stone below and check plumb, or we have to use our electronic survey instrument for that, which is very difficult. In fact, it's better to use your own system, which is much better and you're confident about, because you can't depend on survey all the time. So closing all reinforcing bars by formwork shutters and ensure verticality and alignment by checking plumb and alignment as well. Alignment is very important to check because it's high structure, and so there's a difference, so difficult to control. So alignment means shuttering lines or formwork lines must be according to drawing in that alignment, and after that plumb. First sequence is alignment. All those shutters inside or outside must be in a position, and all portion, whole height must be in a position, and supports at 1/3 and above must be in position, and then plumb inside and outside both around, I think, each 1 meter spacing. It should be checked at many locations, maybe every 2 meter, 1 meter vertically it must be checked, because height is 10 meters or more. So even at every 2 meter you can check and it shall work. And you can check this if you, or you can use plumb bob in combination with your theodolite, can also be done. Provision of working platform to pouring locations and make ready for inspections, plan for concrete pour. Provision of working platform to all places, all locations, and make ready for inspections and plan up for concrete pour, which is very dynamic here, because dynamic in a sense, it's not very fast, it's not very slow, but controlled one. And when it's controlled one, I can say it's dynamic. Speed is not dynamic, effect is dynamic. Then you can say the conduct inspections, quality inspections for pour clearance, and then pour concrete in layers not exceeding 450 mm or 400 mm each, followed by interlocking by vibrator needle to lower layer. Curing of poured concrete to accepted method statements. Again we read these activities in this, which are very important one. These are activities that we define for such height of wall to carry out. We call it baffle wall. Actually it is a retaining wall as well, not only baffle wall. It's written baffle wall, no problem, but it's a retaining wall. It's water retaining structure, so it's retaining wall. This is fabrication of reinforcing bars, neither at fabrication shop or at a site, by your way. Fabrication of formwork sites for walls or procurement of standard proprietary material from vendors based on respective designs to sustain liquid pressure from such heights more than 10 meters, 7 meters means a strong formwork is necessity to register horizontal hydraulic pressure or fluid pressure, which requirements should be provided satisfactorily by vendor. Scaffolding and working platforms shall be provided each reach all heights up to more than 13 meter, including all stepped staircases and relevant protections. Then fixing reinforcement at required locations well tied with connecting reinforcing bars. Inspection of all such reinforcing bars by quality engineer and also others. Providing inserts so far required, and providing water bars and construction joints located as indicated in drawing. And because we are going one way, one height, so it can be only at bottom. Providing tie rods and lost members of PVC and closing all reinforcing bars by formwork shackles, ensuring vertical alignment and verticality all way. Frequent verticality at 2 meters probably in height, and alignment should be done before that. A whole wall and provision of working platform to reach all pouring locations and make ready for inspections, plan up for concrete pour, and then of course and conduct inspections of quality and all, and pouring concrete in layers not exceeding 450 mm each one by to be interlocked to bottom one, interlocked to previous one, and curing of poured concrete to acceptable method statements. Now what equipment we think are there? Concrete pumps required, transfer mixers required, all form of equipments are required, cranes required, maybe token is required to lift all these materials, site, and steel rebars working, all things required. But it's heavy one because it's 10 meters high. So if you think it's 50 meters, we are doing this wall just in 7.5 meters, and then you can say it's 7.5 meters by 0.4. That's 7 meters. So we are taking 7 into 0.4 to 2.8 and 2.8 into 10 meters. Say so 28 cubic meter wall is not easy. 28 cubic meter are going to pour this in one day. Wall wise, it's much more because 28 means your mixer has to stand 8 meter cubic. 3 1 would come. So it will take a couple of hours. But you can't run more than 2 hours. So they have to be very clear about that. What to do? Say seawater basin, minor concrete repairs at kicker face. That's also very important. Once repair one, we have to understand what to do with seawater basin, minor concrete repair at kicker face. Meanwhile, you can say that this is which one I'm talking is, and I can close it also if it's required, and we'll say I can close it. Okay, we'll move to this seawater basin minor kicker repair. Definition, scope, definition, responsibilities all are same. Equipment, material, method, attachment all same. You can say purpose of this statement, which you can say purpose of this statement is to carry out minor concrete repairs. You can say purpose of this statement is to carry out minor concrete repair, especially at kicker face. And say kicker, you know what is kicker? When you have original slab and you want to start wall, that wall some people do called kicker. Kick vertical member, you can say kick. So kicker face where you fix alignment, kicker is well aligned. So your kicking face it is, and you're going to apply that minor concrete repair. Maybe some defects there. So filling of tie rod holes first of all, which is a general snag. Filling of tie rod holes, which is a general snag that occurs on such structures. A reformation of grooves for sealant on floor, slabs and walls is a scope. Now safety definition etc. is there, no problem. So we go further. General responsibilities are already there. Safety means same thing, means what it says. All persons who work on demolition, breaker, grinder, drill, and proprietary products, application should wear gloves, masks, safety glasses, etc. And all personnel to work on forms and reinforcing bars shall use all safety measures required as description include on various other method statements. Material. What material actually is important here? In those days it's the old. I think this was done in 2000, somewhere 2001. So it's about 20 years back I'm talking. It's not today's. I'm not talking today. I'm just giving procedure that was adopted long back. Material epoxy bond agent, let us say. Material is epoxy bonding agent. Forget MBT or something, I'm not interested in that, is written there. Just sample. Epoxy bonding agent, that's permanent epoxy adhesive for internal or external bonding. For renderings, concrete repairs, bonding concrete to concrete, steel and granulate toppings. Then you can say high strength, non-shrink cementitious mortar, ready to use product in powder form requiring only on-site addition of water to produce a non-shrink mortar of predictable performance formulated for use as plastic consistency, use at plastic consistency for bedding. Repairing, grouting and void filling such as concrete repairs, void filling between old and new concrete, filling tie bar holes, etc. etc. That is what to say. Again I say high strength. This is it's a material. This is a compound, you can say. High strength non-shrink cementitious mortar. Non-shrink is very important here because shrink causes problem. So this non-shrink, it won't cause problem. So strength should be high strength, non-shrink cementitious mortar, ready to use product in powder form, requiring only on-site addition of water to produce a non-shrink mortar of you can say formulated for use is plastic consistency. Again I say high strength non-shrink cementitious mortar ready to use powder or from using or requiring on-site addition of water to produce a non-shrink mortar of predictable performance formulated to now says non-shrink mortar of predictable performance formulated for use at plastic consistency for bedding, repairing, grouting and void filling such as concrete repairs, void filling between old and new concrete and filling in tie bar. Okay, then we go to again, I say void filling between old and new concrete, filling tie bars, rolls. Now method, sketch 13 indicating only. I think I opened a sketch last time also. So it was 13 only, same sketch, no problem. Existing surface shall be scabbled. What it says? Existing surfaces shall be scabbled. All loose concrete and mortar, all loose concrete and mortar drippings removed by using a single head scabbler and a Rodcraft model. Other, you can say scalar. Epoxy bonding agent we need. So first we need scabbling machine. All loose concrete and mortar drippings removed by using a single headed scabbler. Then we use epoxy bonding. We can say existing surface shall be scabbled. A scabble means its latent shall be removed. All loose concrete and mortar drippings removed by using a single head scabbler. Epoxy bonding agent, which is a concrete-like 1414. And, we can say epoxy bonding agent shall be applied by brush and allowed to cure. Also, we can say another material, trade-wise limit, be mixed, that is master flow, be mixed with water in small pails, pan actually by hand, complying with manufacturer's details and trowel onto surface. So it's easy, very easy. Approved curing compound be applied immediately. A wooden strip that is 25 mm thick into 20 mm wide. So we can say then our application starts. Approved curing compound applied. Immediately, a wooden strip 25 mm wide into 20 mm deep. Wooden strip, small one, 1 inches wide, you can say 20 mm deep, a kind of nearly square, rectangular, shall be placed at center of joint on existing rebate in floor slabs, as well as walls and space on either side be filled with master flow. To obtain a clear rebate of size 25 mm into 20 mm, followed by removal of wooden part. Then we can see this strip we produce. We have used this, we have to use this. Walls and space by the side be filled with master flow to obtain a clear rebate, that is 25 to 20, followed by removal of wooden strip within an hour of fill and reformed surfaces of sprayed with the approved curing compound. So what it said, wooden strip that is 25-20 deep shall be placed at center of joint on existing rebates in floor slab as well as walls and space on either side of filled with master flow to obtain a clear rebate of X. Cross section 25 by 20. You can say then, after this, again I say, it's this little complicated one. A wooden strip of the size 25 by 20 mm deep shall be placed at center of joint on existing rebate in floor slab as well as walls, and space on either side be filled with MBT master fill to obtain a clear rebate of this, followed by removal of wooden strip within our fill and reformed surface of sprayed with approved curing compound. So what is equipment? We have model, scabbler, light version, manufacturer's catalog. Then now we go to seawater basin. Water tightness, very important item. Water tightness test according to BS 8007 1987. Scope are same. Scope definition responsibilities. This is DEX. Scope definition responsibilities, safety method, procedures, equipment attachment, etc., etc. It goes same. And I can say now. You can say now this about what is that? This is to transport seawater to seawater basin. First of all, to transport seawater to seawater basin and testing major volume basins. Purpose of this statement is to define complete procedures. Transport seawater to seawater basin and testing major volume basins. So we can say purpose of the statement is to define complete procedure to be adopted for conveying seawater by pumping from shore to location of seawater basin on plant site. Since quantity of water required to conduct water tightness test pertinent seawater basin constructed is very high, which is not convenient to be transported and filled into basin using water tankers efficiently and economically. Then definitions are there, responsibilities are there, safety is also there. Now what actually we need additional in this case is traffic directory. Traffic directory signs for ramp breakers on Now you can say a protection arrangement. Let us say traffic directory signs for ramp breakers. Traffic directory signs for ramp breakers, 3-number road crossings shall be installed. There is now, in this case, there is such problem, such obstructions. We have to cross them. So traffic directory signs for ramp breakers we have to provide on exposed pipe route. Safety tags shall be installed with cones. On exposed pipe routes, safety tags shall be installed with cones. Of course, safety measures then. A protection arrangement shall be made for plants at intake. Protection arrangement at intake where seawater exists and we have to pump water from there. A protection arrangement is made for plants at intake. A full-time dedicated attendant. A full-time dedicated attendant shall keep watch and ward en route. So procedure involved in methods is important point. Indicative sketches they are already I shown to you. Now what could be sequence of procedures? That's point of interest here in sequence. That is, we can say here laying 100 mm dia hose 4 inch, you can say laying 100 dia hose from sea to seawater approximately say 1.8 kilometers or more, approximately it is. I just did complete engineering activity in this case. Refer to sketch number, whatever sketches were given there, main take at sea, discharge to basin. So few sketches were included in that, it's not shown here, doesn't matter. Constructing a concrete anchor at sea, to fix intake pipe. Construction of a concrete anchor at sea to fix intake pipe, spout horizontally, that is fix intake pipe spout horizontally and vertically, as well as to fix 2-number heavy duty centrifugal pumps at that point. There are 3-number road crossings en route with the points are mentioned to 5, 6 on which temporary 150 mm dias pipe sleeves are to be inserted in form of ramped speed breakers. Otherwise, sleeves shall be inserted by road cutting, filling and making good and removed when job is over. But preference is to cross road by inserting sleeves and so we say otherwise, no. Sleeve shall be inserted by road cutting, alright, and then install either a round clock 24 hours working generator to supply electricity to pumps with distribution board. So we can say install either a round clock person there, install a generator for full time at foregoing location, may not pose any objection from environment angle or from fire safety since location is far away from plant area. Install a timber clamping platform on ditch at point number 4. Now we have to do some calculations in this, as water head calculations indicating only. And this is what is there. You can just keep in, just keep in there. This is calculations. I just remove use this important item I'm taking into consideration. You can, this you can say intake suction, intake disposal, vertical head loss at point number this and this, and also here. Just a minute, please. We can just think of this and we'll talk together. I think you must have taken into consideration all this probably, which is good one. So I can say that is here. Intake suction is 1 meter, intake disposal is 1 meter, vertical head loss is 25 meter. This is between level from this point to disposal point, approximately 25 meters, and there are 8.8 losses, 10 meters. So we can say total vertical head loss is 37 meters. Total vertical head loss is 37 meters, 27 here, and 10 is here, 27 plus 37 meters. There's head loss during this journey of pipe transportation. Length of pipe for friction loss is 1800 meters. Length of pipe for friction loss is 1800 meter, that is for FLV square or FLVB or 2GD. That's pipe friction coefficient. Pipe friction coefficient being 0.015, and that is 4.015 into length is 1.8 into 155 1.5 over 2 into 9.81 into 1, that's 123.9 meter. That is length of pipe for friction loss. This is friction loss. Total head loss is static loss plus dynamic loss, 37 plus 123.9, 760.9 meter loss. So work done is equal to how much? That is 42,000 into 160.9 kgm. By this you can say BHP is equal to this quantity divided by 27,000, so 25 units. For this work we need 25 units. YHP is equal to 35 units. So water flow velocity has been assumed to be 1.5 meter per second. 1.5 meter per second during this pumping, giving a discharge of 42 cubic meter per hour. 42 cubic meter per hour. It shall take 20 days. It will take 20 days to reach transport this quantity, 20,000 cubic meter water, 20,000 cubic meter water to seawater basin, maintaining round clock pumping. Round clock pump means you need standby pump also. So seawater basin pumping, we need this material, this machine of pump, which could be whatever means standard performable pumps, and we have to see how many it is. See the chart here. Seawater basin plant pumping, if we start day 1 and we go to 21 days, we'll say on one day quantity pumped in 1008 cubic meter here, and we add this every day, so we got here 21,000 something like that. So this first phase testing we have to do. You can see this is the same thing, nothing is added, this Excel from that. So first day is this, second day this, third day like this. Every day you are adding 1008 cubic meter into that, and 21,000 cubic meters then on that day. So first phase testing we have to take care of this. And I think tank completed with protective coatings as specified and sealant applied shall be cleaned. Well, I am not agreeing with this type of item, though I was given this one by person who is responsible for this to coordinate and make a statement, but I don't agree with this. The tank completed with protective coating, because we have to test RCC. So, well, it was mentioned in the specifications and they took benefit of that, and therefore they applied protective coating prior to testing. I don't mind it, but it's not correct. Tank completed with protective coatings, tank completed with protective coatings as specified, and sealant applied shall be cleaned and filled with normal maximum level to meet requirements of clause. Okay, sealant applied is okay, fine, and well, do it, but shall be cleaned and filled to normal maximum level to meet requirement of clause 9.292 by BS 8007 1987. testing of structures. Now, testing of structures, that is up to 11.5 meters. Testing of structures up to 11.5 meters, which should take 14 days and then be retained for stabilizing, absorption and autogenous healing. Period of 7 days for maximum design crack with 1 minute. With this only my objection was regarding protective coating, because joints must be filled for testing. You can't say otherwise water shall leak through joints. So that is different way. You got my point. This you have to go through BS 8007 for this test. This is descriptive one. Only available place where specified information about how to test water retaining structures. So you have to conduct. It says which would take 14 days and then be retained for stabilizing, absorption and autogenous healing. Period of 7 days for a maximum design crack width of 0.1 mm. This was specified. Test period starts now for 7 days and drop-in level recording be made every 24 hours during this 7 days period. Now, total permissible drop in level allowing evaporation etc. should not be more than 1/500 of average water depth of full tank. 1/500 of average water depth of full tank, which limits to 10 mm or another specified or calculated amount. Now, having test been successful, backfill shall be carried out. Now, foregoing explanation provides application of concrete protection coating prior to water tightness testing, but preferably coating should be applied post successful water tightness testing. On site where this projection was carried out, application of coating was made prior to testing. Factually, on projects, decision depends on all team members, including engineer and consultant. Second phase testing. Now, I think I should take break here because already it's nearly 3 hours. We have to review also what has been done today, because this talk of tank is very important for engineers. Water tightness testing, it's very important activity in quality controls. Water testing cause on such plants, it's not seawater basin alone. There were many sump chambers, underground sub chambers, below ground sub chambers, and also many other structures that carried water within it, and there are so many manholes as well. So we have to keep all these factors into consideration. This activity of water tightness test is a very important activity. If you take into consideration this, we cannot take it for granted that we can just move away fast from this. This is, it is time consuming, and if it fails, it creates problem that you have to repair and then do again. That's why I say I have to take care of RCC work, whereof all RCC work must be done very carefully, whether it is concreting, it is form work, it is reinforcement. All these activities are very important. Design is very important, and water retaining structure are particularly, you can say, cause problems. So what we actually try to learn today, something about, you can say, quality, that you can say I talked a lot on that point we discussed in this various factors, various, you can say, various provisions, and we conferred a little on this. This is engineering after all, you can say. This is engineering, and it must be supported by all these factors, without which we cannot move a single millimeter. So one end is quality, other end is engineering. Then we have to of course, we talked of management organizations, of course, and I talked of also my other, you can say, career projects, you can say even. So also I talked of relatively, and we discussed on this you can say this issue is photographs. Of course, then of this you can say this discussed about this let me say these plans we discussed with all in this we did before. So this was about that. Construction of main substation we discussed before. We discussed about these stages before. And of course, you can say now as it comes, you can say that baffle walls we discussed, seawater basin. Repairs we discussed. And water tightness test we are doing. That's very important one. We'll take care of this later on also. It's not easy, so I keep it down. I close this file. I close also this file. Project management. I close also this file. Building plant. I close this file, and I like to give you again sketch of seawater basin. And that is sketch. Yeah, this one. It says which we discussed at length. We discussed this one for purpose of that was this one. Can say we discuss all this. We are talking about this area in this, and now I can say, so you can say that I close this, and now I think, well, we have reached a conclusive point about today's talk, considering various methods in this case. And as I said, for me, methods are very important. To an extent, quality can be maintained or cannot be maintained to that consideration. If we consider we can maintain quality, that's, I think, best way, that's best consideration we can do, we can get into. We should not leave it to time, we should not leave it to circumstances, we should do our best efforts to get that. Being engineers is our responsibility. You cannot say, no, I cannot do. You have to do it. There's no way out. You have to do it. And you have to do it. That's the only way we can move forward. We can move forward and we can move forward. I can say we cannot keep things for, granted. Nothing can be taken for granted. That's what I say. It's not every time so easy. We have to. That's what I can say. It's not simply certification that we have to do. We have to care for everything. And that's what point is. I think you guys, you engineers and others, public members, get my point of view that life is not as easy as we think. Life is different and everything is different. So I take your time now. I want to go now from this talk. Already 3 hours over, and it's a good time that I could talk for 3 hours. And because it's working day, you can't continue for long. I wanted to continue, but okay, these days I'm doing much. I'm, because of so many problems, I'm trying to do at least 3 hours, if not more. That's where it lies in. I want to take. I hope you people shall comment something. I'm not getting any feedback from anybody. Maybe you are not interested in such subjects. At least I want to know, are you interested in such talks, or you're not at all interested? Even then, it becomes a kind of resource for you people to stay in this. Without that, it can't be done so well. It's up to you people. There's no force anybody. If you want, you can do it. If you don't want, you can do it. It's up to you. I have just sharing my experience with you people. If you are interested, fine. And otherwise also, sometime you will need it. If you are in engineering, you continue throughout career of your life. It doesn't mean today if you are talking something, it can't be used after 10 years. These work for decades. This work for 50 years before, whatever was there, still today is there. Bending moment formula is still same. So we have to be very careful about this. Thank you very much.